puzzle. I've got it on the board. And then when you get it, I'll give you a few minutes to start trying to solve it on your own. And then we will solve it together. Remember, we want to look for the equations that have the smallest amount of unknown numbers so that we can figure them out. All right, let's go ahead and start figuring out where to start. Where should I start if I am trying to solve this puzzle? Remember, I'm looking for the smallest amount of unknown numbers so that way I can figure out what that unknown is worth. Shelby? Yeah, I'm probably going to start in this third equation that bow equals 9 minus 3 plus 2. Let's start with the first part of this, 9 minus 3. What is 9 minus 3? Shelby, 6, yep. And then I can continue on with the rest of my equation, 6 plus 2. What is 6 plus 2? 8. That means my bow is equal to 8. And that means this bow is also equal to 8. Which equation am I going to start trying to solve now? We've done the third one. We figured out bow. Bladen? The fourth one, present plus 8 equals 15. 7. So that means this present is 7. This present is 7. 27. Where am I going to look now? Elena? Well, look at that second one. Cookie minus 7 equals 3. Is it 4? No. No. Some people think it's 4 because they see a 7, a subtraction, and a 3, and they think, oh, 7 minus 3 is 4. But 4 minus 7 is not going to give me 3. Yeah, 4 minus 7 is not going to give me 3. 4 minus 1 gives me 3. 7 minus 4 equals 3, but I have to put one where Cookie is. Logan, what's Cookie? 10 minus 7. That is equal to 3. That means this cookie. Look at 5. Can you figure out what milk is in that top equation? Can you figure out what milk is in that top equation? Jackson? 5. 5. How'd you figure it out?
Because I know those two cookies were 10. And if I minus 5, it would equal 10.
Yeah, so Jackson said, okay, I looked at 20 minus something equals 15, and he knew that something was going to be 5, so milk is equal to 5. Very good. All right, today we're going to be looking at all the different ways that we can build an equation, because sometimes how an equation is written might not be the easiest way for us to think about it, and we can rearrange it to make it a little easier for our brains. Go ahead and turn to the next blank page. Title is at the top. It says using part-part whole to rewrite equations. Using part-part whole to rewrite equations. You have seen part-part whole. You've used part-part whole. Part-part whole just describes the relationship between some numbers. When I am using part-part whole to help me solve a problem, I'm looking at the relationship between my parts and how they add together to give me my total or my whole. just a way so I can manipulate those numbers. Logan?
It must be that exclamation mark.
The question mark is your whole. Logan knows that because he knows when we subtract, I have to start with all the things. That means Jackson 5 is what? Is it a whole or a part? It's a part. And that means 1 is a part. I could write this equation another way. I could write question mark minus 1 equals 5. I can change out my parts. Remember, when I subtract, I'm just finding the difference between those two numbers. So whether I say 1 to 5 or 5 to 1, that's not going to matter. Yes? No?
What if you change the whole with the...
I can use subtraction, so that's the only other subtraction. I can't mess with my part. But I can do something else. Shelby? I can use addition. When I add, do I add my parts or do I add my whole? Parts. What are my parts again? 1 and 5, so I might say 1 plus my other part is 5 equals question mark, my whole. Is there another equation I can do? Harper? Yeah, I can use my commutative property. 5 plus 1 equals question mark. I will tell you, this equation right here is probably the easiest for my brain to think about. I can figure out something minus 5 equals 1. I can figure it out. But it's way easier if I just rewrite this equation as an addition problem to figure out what question mark is going to be. Did we do any addition or subtraction? No. We're just rearranging our equations. Let's try another one. Question mark plus 17 equals 32. Go ahead and see if you can come up with another equation. Think about what is your whole, your total, and what are your parts. Said, okay, if I'm doing another addition equation, I can't do 17 plus 32. Why can I not do that one?
Because 6 plus 32 will be way over 17.
Okay. Which one of these is my whole? That's my total. It's not getting any bigger than that. 32 is as big as it's going to get. Lincoln, what's one of the equations that I could come up with?
32 minus 17 equals...
32 minus 17 equals question mark. Did anyone come up with a different one? Michael?
15 plus 19.
17 plus question mark equals 32. Yeah? Anyone come up with another one? Gwen?
Can you do 32 divided by 17?
No.
5 question mark.
No. We are only working in addition. Addition and subtraction are inverse, so we can manipulate those two. But we can't go from a subtraction problem or addition problem into a division problem unless I'm doing repeated addition. Does that make sense? Because remember, multiplication and division, we're counting groups. So if this said 17 plus 17 plus 17 plus 17, I might be able to do some division because I have groups of 17. But I don't have that here. Did you come up with another equation? Yep, we already have that one. 32 minus question mark equals 7. 17. I don't think that equation is going to be particularly helpful, but you could make one. Devin? Can I do 32 plus 17? 32 is my total amount. It's not going any higher than that. So if I say 32 plus 17, am I going to get a number bigger than 32? Yeah, that's not going to work.
49.
That's not going to work. All right, we're going to skip this next one because it's another subtraction. What about this one? Go ahead and write it and see if you can come up with another equation. It says 9 times 5 equals question mark. Yes? Let's finish this first. Braden asked a good question. He said, are you allowed to use division? What is the inverse or the opposite operation of multiplication? So, would you use division? Yeah. Yeah.
10 divided by 10 equals 10.
What's another equation I can write? What's another equation I can write? Elena? Yeah, we have that commutative property again. 5 groups of 9. 5 times 9 equals question mark. Will?
Question mark divided by 9 equals 5.
Yes. Remember question mark when I'm multiplying in this equation, it's like our total. It's our whole. When I'm going to be dividing something, I'm going to need to start with that. Dividing, putting into, what did you say, 5 groups or 9 groups?
9.
9 groups equals 5 in each. Is there another equation? Finley? Yes, question mark divided by 5 equals 9. We got that. We're almost done though. We're almost done. That is a division symbol. I'll rewrite this equation just to make it a little easier. Remember, I can't write division on my computer. Yeah, 54 divided by 6 equals question mark.
Ooh.
Put it up. Put it up. 54 divided by 6 equals question mark. We're coming up with some other equations. Think about what is your whole or your total. Think about what is your parts. Jackson, do you have another equation I could come up with?
6 divided by 4 equals question mark.
Not divided by.
Times.
I'm going to be multiplying. If I'm working with my parts, I need to multiply those groups together. And then my total is 54. That will work. Michael, you got another one?
Question mark times 6 equals 50.
Question mark times 6 using that commutative property. Do you have one? What?
6 plus 54.
So I'm not going to be able to use plus because I'm working with multiplication and division. Those two are opposites.
Times 54?
So I can't do 6 times 54 because 54 is my total. It's my whole. I'm not going to be more than that.
But you did 54 times 6?
Nope. I'm not going to start with my whole to multiply because that's my total amount of things. If I want to start with my whole, I'll have to put them into groups. So I'll have to divide. So I might say 54 put into question mark groups equals 6 in each one. The reason why we are practicing this is because sometimes you'll see an equation, maybe one like this, and you're like, ooh, I know how to divide. No, thank you. But it's not my favorite. It's a little tricky for me. But you know that you're a good multiplier, and you know that looking at it like this is easier for your brain. Could you do that?
Yes.
Yes, you can. sometimes the equations that we write aren't the easiest for our brain to figure out. But if we know that we can rewrite them using what we know about part whole, that makes it a little easier. Michael? An addition equation? I could, but I'll have to take it from a multiplication equation. So this might be 6 groups of question marks. So question mark plus question mark plus question mark plus question mark plus question mark 1, 2, 3, 4, 5. 6 groups of question marks equals 54. So maybe not helpful, but you could. And if I did this one, question mark groups of 6, well, 6, I don't really know how many 6s to do. Some amount to get to 54. Today we're going to be looking at some other ways to show unknown numbers. We've talked about this. I typically just use question mark or box, but could you use smiley face? Yes. Does anyone know what the unknown number is on your math choice board? No. What is the unknown number? What's the unknown symbol on your math choice board? Some of you have asked me about it. On your math choice board. Ashlyn? It's an M. It's still just a spot saver, even though it's the letter M. Oh. Could it be a smiley face? Yeah. Could it be a bow? Yeah. No. Could it be a Christmas tree? Yeah. Could it be Miss Miller? So we are going to work on what's